So in the last lecture, we looked at how we're going to use the class mechanism of C++ to add the ability to deal with rational numbers. And the rational numbers will come built into C++. So we're going to use the class mechanism to create a class that we called rat that will enable us to do that. So we saw, first of all, what the mechanism was, what it looks like on a high level, namely you declare that you're introducing a new data type by saying class and then the name of the class, which is rat. And then we saw there were two parts to it. The first part is which is private, and you tell the compiler what the rat looks like. So when you say something like rat x, what is this thing going to look like? And we saw, right? So this is the private part, and we said a rational number is going to be two integers, one next to the other, and we tell the compiler we're going to call one n and one d. So anytime we create a rat, that's what the layout is going to be. And then, so that's the first part. And the second part, which we call public, is we say what the objects of this data type can do. And the reason it's public, of course, is because we want the users to be able to do this. We want them to be able to declare rats. We want them to be able to change rats. Eventually, we're going to see today we want to be able to add rats and subtract rats and multiply rats and input rats and output rats. So, of course, since we wanted to use it, they have to be declared to be public. Okay, so that was the first thing we did. So after we saw how to declare those things, we then looked at some of the member functions. And specifically, we looked at the constructors and then the getters and the setters. So the constructors, what were the constructors about? The constructors were initializers, and we saw that constructors have a special they have a special syntax. Namely, all constructors have the name of the class as the name of the function, and what distinguishes one constructor from the other is the parameter list, right? And also, we saw that constructors have no return type, because they don't return things, not even void. What they do is they initialize, right? They're initializers. They construct it so that we can then use it. Before the constructor is run, whether a default constructor or whatever, it's not really ready to be used. So we saw a number of constructors. These go over here, of course, because they're public member functions. We saw the default constructor. What makes it a default constructor is it says, we're not passing any arguments into it. So we have to tell the compiler what we do when we write something like rat x, right? What do we do? How does it construct it? So we said if we do that, we can do anything we want, but we said we want to put a 0 here and a 1 over here. And then we saw the two-parameter constructor where I could say, x is a rat with 1/2, and that's going to put a 1 in here and a 2 here. And how does the compiler know which one to use? Well, because it sees how we've declared it. If I say simply rat x, then it's going to use, if I say, like, I have a rat and my rat's name is X, so it's going to use this one. But if I start putting arguments in here, then it's going to pick the one with the argument. And finally, we saw the conversion constructor, so I can say I have a rat X, and 5. Now, 5 is not a rational number, but we realize that 5 is really the fraction 5 over 1. So if the compiler sees this declaration, it's going to check the list of constructors, and it says, is it going to be this one? Is it going to be this one over here? Well, no, it can't be that one over here, because this one, this default constructor, it takes an argument. Could it be this one over here? Well, no, because we're only giving it one argument. So it does a matching of the parameters to see which one matches the closest, and it's going to say, it must be this one. So when I say rat x5, it's going to take this, put it over here in I, and I is going to go into n. That's going to be the numerator, and the denominator is going to be 1. So that's going to give me a rat that says 5 over 1, and that's clearly a fraction. Okay, so we saw the default constructors. We saw how to tell the compiler, right, what the layout is, and we gave it some default constructors and other constructors. And then what that lets us do is declare a rat and initialize a rat. But then we also saw how we can change rats, and those were with the setters, and how we can read the internals of a rat, and those were with the getters. And again, those are not C++ built-in terms; they're just terms of art that people use in the programming community, right? And so if I have a rat, let's say, if I say my rat is called X, and X is 1/2, so initially, right, what does that thing look like? Well, it looks like, here's my rat X, and this is the numerator, and that's the denominator, and that has a 1 and a 2. Right, that's what it looks like. If I want to change X, right, so I can say X dot, and then I can say set the numerator, right? So I call the function, put the dot over there, and I say set numerator, and then I pass in the value that I want. So if I set the numerator to 5, it's going to go to my rat, and it's going to change the numerator, right? Because we're going to give it, this is set numerator. It's going to take the I, which is the parameter, and put it into the n part, right? And that's going to do this, and it's going to set that to a 5, right? And we saw the same thing with the getters. We covered that last time in the other in the previous video. So this is where we're up to right now, and we want to get the rat. We want to be able to let our rats do arithmetic, and so let's see how we do that. We're going to start with the addition of two rational numbers. So if x and y are rats, we want to be able to do something like x plus y, right? So, of course, rats don't know how to do that. Rats don't know how to do anything unless we tell them how to do it. So how do we do this? So what happens is that C++ provides a number of built-in functions, and they have the following names. Like for plus, it's called operator plus. That's really the name of the operator. It's called operator plus. And there's also an operator minus, and an operator times, and an operator divide, and there is an operator bracket, and there's an operator paren, and so on and so forth. And the thing is that even though, let's say, operator plus is called operator plus, we can make it do anything. We can, when we define the function, right? Because this is just these are built-in names of functions, but they don't mean anything. I mean, the point is we can do anything with these names that we want. So, for example, we can define operator plus to mean subtract. We can make it multiply. We could make it make a phone call to order, sandwiches from the takeout. We can make it do anything that we want, right? But of course, what you're really going to do is you're going to use the operator plus, because the trick is you want the reader and the user of your class to sort of identify with it, right? So if you want to define x plus y, you're not going to define it, with a multiply operator, because in software design there's an important principle called the principle of least, L-E-A-S-T, surprise, right? The principle of least surprise. In other words, if you want to define subtraction, don't use the multiply operator, right? So if you want to define something like a plus operator, and C++ provides you with an operator plus that you could define, so use that, right? That's why if x and y, say for example, are strings, then the plus operator is used to define concatenation for the string class, right? Because it sort of makes sense, right? It sort of means add one string to the other. So let's see how we do this. So before we actually look at the code, let's make sure we understand how you add fractions. So let's say I have a fraction, two fractions. I have a fraction a over b, and I want to add it to another fraction c over d. So you might remember how you did this in elementary school. What you did was you cross-multiplied. You said this was the following. You said a times d, right? A times d. You're going to write times explicitly, right? A times d plus, right? In other words, this way, you cross-multiplied, plus b times c, and it was over b times d, right? That's the way you defined it. But what we want to do over here is we're going to have two rats, right? And one rat is going to be called x, and the other rat's going to be called y, right? And these are in fact rational numbers. So let me actually write them like this, right? We wrote them beforehand. So this is the numerator, let's say, and that's the denominator. And this is the numerator, and that's the denominator, right? We had them lying down before, right? We'll write them like this. So right away, there's a problem here, right? How do we, if both x and y have numerators, so we want to multiply the numerator of x times the denominator, and it's going to say n times d, right? It's going to say n times d, and then it's going to say plus d times n. Well, how is C++ going to distinguish between which numerator and which denominator if both are called n and d, right? So it's a good question. So the answer is that here's how things really work. Here's how things really work. The name of the function is operator plus, right? Let's just read this. This says the function is called operator plus, and what it's going to do is it's going to add rats and it's going to return a rat. So just like when I add two integers, I return an integer. When I add two fractions, I get a fraction back. But I want you to notice that if I add x plus y, right, if I add x plus y, so there are two rats over here, but in the definition here, there's only one rat. So how does this in fact work? Which one is x, which one is y, and so on, right? So you might recall what we just did before. Let's look at let's say the set n function, right? So if I have some rational number x, and I want to set the numerator, right? I want to set the numerator, say, to 5. So what happened over here, right? So I'm doing this one over here, set the numerator to 5. So I went into the numerator. So notice whose I is it? Which I? There's no I over here I mean, who's n? It says I goes into n. We just simply said set the numerator to 5. So I, which was the parameter, right? I is the parameter here, and the argument is 5. We put that into n. What n? So we see that when we use this syntax, the n is even though it's not written explicitly, the n is the one that belongs to the object upon which you are calling this member function. That's very, very important. So the general syntax is the following. On the left-hand side, whenever you call a member function, this is the way it really, really works. The left-hand side, you have a member function, then you have the object upon which you're working, then you write a dot, then you write whatever the member function is. So in this case, on the left-hand side, the object was the x, the member function was the set n, right? And that function happened to have a parameter. But it's also important. So therefore, it's the same thing over here by addition. When I say x plus y, what this really means, right? When I say x plus y, it really means the following thing. X plus y, that's the same as saying, this is an example of what we call syntactic sugar here. What this really means in C++ is take x on the left-hand side, dot, operator plus, right? We're explaining this. We can do this, but this is syntactic sugar, as we said before. X dot operator plus, and we're passing in y. Now let me just talk about that expression, syntactic sugar. That is something people talk about all the time in C++. And the idea is the following. Would you rather, when you're adding x and y, would you rather write x plus y, right? Or would you rather write this guy over here? Of course, you would write x plus y, because it's clear what it means. This is a more complicated, it's a clunky expression. If you want to add, so it gives you the ability to overload this operator, right? Overload means this operator plus has multiple meanings. If I just show you this, and I say, what does this mean in C++, this operator plus? You have no idea. It could mean adding integers. It could mean adding floating point numbers. It could mean concatenating strings. And it could be anything that if there are classes and then in that class they've overloaded the plus operator, it can mean that too. So everything depends on context. So when you see x plus y, the compiler is going to say, well, I know what x and y are in this context. They are rational numbers, right? Because you said rat x, and you said rat y, and so on and so forth. So these are two rational numbers. It looks into the rational number class and say, is there a operator plus defined? And since every call on a member function looks like this, a member of the class of the x, right? It's an object in the class, and then a dot, and then some function with or without parameters. So that's the left-hand side of the plus is by definition the left-hand side of this, right? So when I say x plus y, I'm really calling x dot operator plus of y. Now, x over here, this x has a numerator and it has a denominator, right? And this y has a numerator and has a denominator. So here is the rule in C++. If I am referring to the data members, what are the data members of my my rat class? There's only two data members. It's the n and the d. So if I want to refer to the data members in a member function, if I'm using a member function, and I want to refer to the data members of my class, I just use them directly. So if I want to talk about n, I just say n. If I want to talk about d, then I say d, right? So how do I refer to y's n and d? Well, since the y, right, when I say x plus y, x is on the left-hand side and y is coming in via the parameter, so then I refer to the n and the d through the parameter. So this will be called, the x's numerator and denominator will be called n and d, but y's I'm going to be referring to as r dot numerator and r dot denominator, r dot and r dot d. Now, then I can of course distinguish, right? Because if I mean x's, it's just n and d. If I mean y's, since the parameter here is called r, and y comes in through r, I say r dot n and r dot d. Given that, we can now write what we mean by adding two fractions over here to rats, right? So the first is going to be n times this, but now y's is no longer called n and d, right? What is y's called? Y's numerator and denominator are r dot n and r dot d. So let's now do this. Let's do the, so what's the numerator going to be? The numerator is going to be n, which is the x is n, times, right, this way, right, times r dot d plus the d, which is x is d, times r dot n. See, now there's no ambiguity, and so it's this plus this divided by the multiplication of d times r dot d, right? So so this is going to be the numerator of my rat, right? What I have to do here in this operator plus is, well, I've got a y coming in here, and I have an x that's I'm going to be using as, say, x dot dot or x plus y, so, and it's going to be returning a rat. What I have to do in here is to construct a rat and then return the rat, right? Because this says it returns the rat. It's going to be the rat that is the addition of the x and y. That gives you a rat back, so that's why I'm returning a rat from the operator plus function. So here I have to construct that rat and return it. So what I do here, notice it's returning a t, and t is a local rat, and it's going to be returning it by value, right? Notice it's by value here. So t dot n, right? So let's see what's going on here. So this is t. What is t? T is a rat that I'm going to be returning. So what is going to be the numerator of t? What's the numerator of t? Well, t dot n, right? T is an object, and how do and I'm a member function, so I can refer to the numerator and denominator by explicitly using their name. So for the rat t, the numerator of that t dot n is going to be what? T dot n is going to be this thing over here, right? The numerator is going to be this thing here, which is what? Which is n times r dot d, right? N times r dot d, that's this here, plus d times r dot n, right? D times r, that's the numerator. So I put that into t dot n. So that's this. And what about the denominator? So the denominator is going to be just this. So this we've taken care of, right? And the denominator, just make that clearer. It's going to be that, right? And the denominator is going to be this, right? So that is what? That is d times r dot d, and that's going to go right over there, right? That's going to go right over there. So that's it. And then, so I construct this, right? And then I return this, and that is how that's how I do addition. Okay? So just let me do a quick run through of this so it sort of makes more sense, right? Let's say it again. So basically, if I want to add two rats, and the rats are called x and y, and I say x plus y, so that really becomes what? That really becomes x dot operator plus of y, right? So x the left-hand side, so I can explicitly use the n and the d, and over here, this coming through r, it's going to be r dot n and r dot d, and then I just do the, when I add them, so I'm going to get a rat out of there, and I just do the cross multiplication this way and that way, right? And that's what this thing does. And when I return a t, it's going to give me the right value. So I can say something like this. I can say in my main program, look, I have a rat x, which is 1/2. I have a rat y, which is, let's say, 2/3. And I have a rat z. So I'm going to say z, we haven't done an assignment yet, but let's assume we can do that. Z is equal to x plus y. So what's going to happen when I do this, the compiler is going to generate the code that's going to say z is equal to x dot operator plus of y. It's going to do this whole thing, right? There's a thing over there, and then it's going to assign it to z. And so that's how we do addition of the rats, right? So my user can actually write in the class. They can write. It's pretty cool. You can't do this, say, in a language like like Java, because Java doesn't give you the ability to overload your operators, to use the built-in operator names and to give them additional meanings. You can do it though in Python. Okay, so let's dig down here a little bit more. Let's just dig down a little bit more over here, because watch this. Okay, it seems to make sense. It's fine, right? So when we say x plus y, we just finished saying that that's really x dot operator plus of y, right? The question is like this: how many parameters does this thing have? How many arguments does a function operator plus have? Well, it seems that there's only one argument over here, right? I mean, x here is on the outside, right? So it's x dot operator plus of y. And we said that if I want to use x's numerator and denominator, I simply call them n and d. And if I want y's, I call them r dot n and r dot d. Okay, that's all good and well and good, but I understand how I can say r dot n, r dot d, because y is explicitly passed in, right? Operator plus is getting the parameter on the right-hand side, right? When I say x plus y, y is going in there. It's going into the r. But how do I get, how do I get inside here? How do I get the n and the d? I'm not passing it in, right? That x is on the outside. So how does the operator plus even get a hold of the n and the d, right? It's an excellent question, I think. And the answer is quite interesting, but I want to point out that this really should have come up a little bit earlier. Let's say take a look at the getN, right? Let's say getN, right? So in the getN function, how do I use the getN? So let's say x is a x is a rat, and I say x dot get numerator and so on. No arguments here. And what do I do in the getN function? So I can use n. So it's exactly the same problem. I'm not passing any arguments in here, and so x has a numerator and denominator. But how does the function get a hold of x's numerator and denominator if I'm not passing any parameters in? It's the same issue as we had before, right? And if you look at this, and the question is how many parameters does get numerator have, you're tempted to say 0, but that's not right. It really is not 0, but it's really 1. And likewise, it doesn't seem like 1, right? Likewise, if I look at operator plus of rad n, and I ask how many arguments, how many parameters being passed in, well, count them. 1, you would say 1. That's not true. The answer is really 2. How can it be 2? There's only 1 being passed in. So the answer is that there really are 2. And what happens is that when I say, the compiler does a lot of work over here. So when I say x plus y, what's really going on is the following. I say x plus y, right? This is syntactic sugar, right? It lets me use the plus to to really be a shortcut for saying x dot operator plus of y. But this is also a shortcut. What this really means, the compiler is going to take this expression and it's going to do the following thing, right? It's going to do the following thing. It's going to say, okay, you're passing in one parameter. I'm going to add another parameter to it. I'm going to transfer this this operator plus that you wrote over here, into the following, my own version of operator plus. Now, before we do that, can I actually write x plus y as x dot operator plus y? Absolutely. I can do this because this is the real way to do this. This is the basic way to do this. The fact is that I can also do this. That's the trick here. That's what C++ lets me do. But I can certainly use the real name, right? X plus y is syntactic sugar. Again, why is it called syntactic sugar? Imagine you want to give sugar, you want to give a bitter medicine to somebody. So you want to sweeten it up because you don't want them to throw it up, right? So you take the bitter medicine and you put it in a spoon and you mix it with the sugar, and so it's somewhat sweet. Sometimes the syntax, going to see, this is nothing compared to what we can see later on. The syntax in C++ could be very bitter. It's very complicated syntax. So they put sugar in there, right? They let you write something that's simpler and clearer and sweeter, and it'll do the translating for you, right? So I can write x plus y, and it really means x dot operator plus of y. But so this is step 1, and this is step 2, but the compiler's version of it is the following. This looks like a single parameter function. In fact, it is, but just look at it. There's only one parameter there, right? But the internal function looks more like something like this: operator plus, and now there are 2 arguments, right? The first, in this case, it takes the address of x, and the second one it passes in as y. So in fact, even though when we look at this thing and we say how many parameters, right? How many parameters? You're going to say 1. But in fact, in the final version of this thing, right? In the final version of this, there's 3. There are 2 parameters, really. So if the same thing that happened back there when I say get n and get the numerator, and I say, well, how did it get the n? How did it get the numerator out of the x? And the answer is because it translated, right? You wrote x dot get numerator of, get numerator, and it translates it into its own version of it, which is get numerator of the address of x. So it really passes it in. So it has access to the internals, right? If you give me a pointer to something, the address of something, I can use that address, that pointer, to get at the internals of the object, right? That's, you just remember we spoke about this when we spoke about pointers, that if I have a pointer to something, I can access it, I can change it, I can do anything. Well, here, instead of accessing just an integer or a float and so on, I can access the elements, the data members of the object that I'm pointing to, and that's exactly what's going on over here. So so what's the name of, right? One more step here. What is the name of this the parameter here, right? This is the value that's going in, and y is the value that's going in. So we saw that the value that y is going in, it's the variable r. What about this? What about this guy here? So it's called this. THIS. That's what this is, right? It's called this. So what is this? What is this? So this is a constant pointer to a rational number, right? It's a pointer that you can't change, and it's pointing to a particular rational number, right? Which rational number? It's in this over here, this guy here, right? Where it's getting the address of x. You cannot change what it points to. It's always going to point to the x on the left-hand side. Now you can change the x, but you can't change the point. You can't change what the point is pointing to. You can't say, I don't want it to point to x, I want it to point to z, also another at. You can't do that, right? It's a constant pointer. So that's how it gets access to the internals. Okay? This is really crucial, right? This notion of how this works and so on. Now, as with any pointer, if I wanted to rewrite the operator, if I wanted to use this explicitly, how would it really work? What would I have to say? So, in other words, if I go back over here, right, and I said numerator and denominator, what did I write? Let's just check it out over here again. So I said the following. Did I erase it already? Hope not. I think I erased it, right? So what I said before was, it looked like this, right? This was the numerator, and this was the denominator, and this was r dot numerator, and this is r dot denominator. So this became what? We said the t dot numerator was really n times r dot d plus d this way, right? D times r dot n, right? That was the numerator, and t dot denominator was simply the denominator of x times the denominator of y, right? So this is what we looked at before, but now where did I get the n? The fact that I can use an n really is because there's a this pointer passed in, and in fact I have access to this pointer. I have access to the this pointer. So if I want to, there's really no reason that I would want to do this, but I just want to show you how the thing works. I could really write it like this. I could say t dot n is equal to, well, how can I say n? How can I say n? Because n really is a pointer to x, right? X is on the left-hand side, right? Here's x on the left-hand side, and this is a pointer to this. This has a numerator and denominator. So this is a pointer to this. What is another name for this? This is something we've seen many, many times. What's another name for x? X is one name, but if this is pointing to x, this has another name as well. Its name is what? Its name is dereference x, right? When I dereference this, right? So this has two names now, right? There's this guy over here. He's called what? What is his name? I mean, how do I get to him? I don't know. His name on the outside is x. But since this is pointing to him, another name for him is dereference this, right? So how do I get at the numerator? Well, the whole thing is, how would I say the numerator of x? I would say x dot numerator, right? But I could also say, since this is pointing to it, this is another name for x. I would say star this dot numerator. And I would say star this, right, dot denominator. So, right, I hope that makes sense, right? Because if x is the name of this, I have a pointer to x. By dereferencing x, I get another name. We saw this many, many times. Spent a lot of time on this. So therefore, when I write this one, right, when I write, tn, and I write it's n times r dot d, right, n times r dot d, I can really write it as star this, right, dot n times r dot d. Now, I don't want to do this, but if you do this, you can just try it. You'll see it works, right? So that's how C++ gets access to the numerator and denominator on the outside, right? It's important to know about this. Also notice another way to write this, and most of the time you'll actually find it written in the following way. I just wrote that I'm passing in a rat that's r, but very commonly you're going to see it written like this. You're going to see not just rat r, but you're going to see const rat r, right? Because if I'm adding x plus y, right, there should be nothing in the arithmetic, nothing in the arithmetic operation of plus that's going to cause any change in y. So if I want to make that explicit, in fact, if I were the designer, not the programmer, and I wanted to make sure that the programmer doesn't mess up and play around with the r, which is the y, when I declare it a const like this, I'm going to be able to read the numerator and denominator, right, .r, .x, r, .y, but I will not be able to change the numerator and denominator in that rat. And any attempt when I write, if I were the programmer, if I were to write the operator plus, and if I say this is a const, any attempt on the programmer's part to change the n and the d in r won't compile, get a compiler error, right? So you'll see it more like that, right? A const rd as opposed to just rd. So that is how you define addition. Now what about multiplication? Let's say if x and y are rats, I might want to do x times y, right? So how do I do that, right? I would want to put it into the class, but the class that I gave you, this rat class, doesn't have that defined. But of course, we want to be able to, complete it so I can do everything arithmetic on rats. So how do you think we will do it? It's not difficult at all, right? Because if I have, what does x look like? What does x look like? So x really has a numerator and denominator, right? And I'm going to define something, let's say operator times, and just as before, I'm going to say, what I'm going to pass in here, I'm going to have a rat, let's say like we saw before, a const rat r, right? Why do I call it r? Maybe just because it's on the right hand side, right? I can call it anything I want, but let's say r. and it's going to return a rat, right? Because when I multiply two fractions, I get a fraction back, two rats, and so on. So since it's going to return a rat, I have to do what I did before. I'm going to say that I've got some kind of rat t, right? Some local rat t. And what is t going to look like? T is going to have a numerator. There's t. It's going to have a numerator, and it's going to have a denominator. So within the member function, I'm going to be able to call it t.n and t.d, as we just saw before. So what is going to be the numerator? If I multiply, x, which is n over d, and this is coming through r, so this is going to be r dot numerator and r dot denominator. How do I multiply fractions? Okay, this times this and this times this, right? So t dot numerator is going to be what? It's going to be the product of the numerators. T dot numerator is going to be n times r dot n. And t dot denominator is going to be the denominator times r dot denominator. And then as before, I'm going to be returning my rat t. And that's the whole story. So I'm going to ask you to finish this class up. We have add, we have multiply. I'm going to ask you to do subtract and then divide. Now there's one other little, there's two things here that I want to also point out. And as let's say I do the following thing. Let's say that my rat x is 1 quarter and my rat y is also a quarter. So you say that I have a rat x, and x is, let's say, 1 quarter, right? So let me write a little bit bigger here. So rat x one quarter, and I have another rat y is also 1 quarter, and then I have a rat z. And now I say z is equal to, and assume I know how to say equal, and I say z is equal to x plus y, right? So what's going to happen is I'm going to be adding a quarter and a quarter, and what is a quarter and a quarter going to come out to? It's going to come out to, of course, 2 quarters, right? But I don't want to write 2 quarters. I want to somehow get 1/2, right? So I need to be able to have some function that's going to reduce these fractions for me. I want to be able to change the addition and subtraction and multiply to add the fact that these fractions come in, I get the lowest terms. And it's very, very easy to do, right? What you do is there's a function that you wrote in 111, I think. It's called GCD, the greatest common divisor. And if I have, let's say, the greatest common divisor of 2 numbers, let's say n and d, it's going to give me the largest number that divides both. Right, so after I do this, I'm going to get, let's say, t dot numerator and t dot denominator. I'm going to get those values. If I divide both of those by the GCD, I'm going to get it into lowest terms, right? So what I'm going to ask you to do is, when you write the programs, I'm going to ask you to make sure that the program gives you the lowest, that the fraction is reduced. Not only that, let's say, for example, I add 2 numbers and I end up, let's say x and y are rational numbers, right? So this is the first problem, right? First problem is when I have to do the reduction. And then the second problem is, let's say I have a fraction that's, let's say 5 thirds, right? So it's a mixed number, right? It's going to give me 1 and 2 thirds. So I'm going to ask you to print these things out, but I don't want you to print it as 5 thirds. I want you to print it as 1 and 2 thirds. Well, how would you do that? How would you do that? So you have to figure out a way of getting the 1, right, and getting the 2 thirds. Well, how would you get the 1? What happens when you say 5 over 3 in integer division? So you get a 1, and then how would you get the 2? You know that the denominator has to be a 3, but this is going to be the mod of the 5 and the 3. So it's easy to take this and get the mixed fraction out over here. If it didn't make any sense, listen to it again, but it's pretty straightforward. Okay, so those are the 2 things we spoke about. The first is You want to reduce the fraction. If you get 2/4, you want to make it to be 1/2, and if you get a number like 5/3, you want to be able to get 1 and 2/3. Okay, especially if you want to print it out and it should look decent. Okay, so let's see where we are at this point. We can add two fractions because we overloaded operator plus. We can now, saw before, we can multiply two fractions. And I'm going to ask you to write the divide and subtract and so on. Let's see, how about something like this? If I have x and y are rats, right? Can I say, so x is a rat. Let's say I give them value somehow. And y is a rat. And I want to say y plus 5. And then I want to take, this is, of course, if it works correctly, this will give me some kind of rat, right? And I want to take the rat and assign it to x. So I know, and I have an operator plus, right? But my operator plus takes a, what does it take over here? What's the argument that I pass in here? It has to be a rat. And when I have x, as we saw, when I have x plus y, that's going to be x dot operator plus y, right? This is going to become what? The left-hand side is going to be y dot operator plus of 5. So the compiler is going to say, look, I know this is a rat, and I know this is supposed to be a rat, but it's not. It's an integer, and I don't know how to add a rat and an integer. But then it says, well, let me go check to see if there is a conversion constructor. And we spoke about that. And why is it called a conversion constructor? It converts an object of a different type into the class that you have. So, for example, the conversion constructor is a member of the rat class, so it's going to convert something into rats. In this case, it's going to convert the integer into a rat, so it's going to do it automatically, right? And so this will become the equivalent of y dot operator plus on, and the compiler in the background is going to write rat of 5, and so this will become like some rat z that looks like this, that has a 5 in the numerator and 1 in the denominator, and so this will work. That's pretty cool. But what about something like this? How about the same thing as before? I have an x and a y, and so I want to assign to x, right? So I'm going to say, and assuming again we can do assignment, I want to say x equals to 5 plus y. So what is the compiler going to translate this into, right? There's a problem here. What is it going to translate into? It's going to say, well, I know this is plus. Since this guy here is a rat, this can't be integer or arithmetic or anything. It has to involve rats. So it drags out the operator plus for rats. But what is that going to? It's going to try to do the following thing. 5 dot operator plus, again, let me write it so it's clear. 5 dot operator plus of y. So this part is okay, right? Because y is a rat, and you're supposed to have over here a parameter that is a rat. But as we saw, the left-hand side, the object upon which the operator is going to be called must be an object of the class. In this case, it has to be a rat. 5 is not a rat. And you might say, yeah, but wait, we have a conversion constructor. Doesn't work, right? It will not do that. It'll only do it over here when you're passing in a parameter, but it won't create an object for you upon to which operate, right? It won't create an object on the left-hand side for you to call one of the member functions. So this does not work. Now this is really embarrassing because here the whole idea is I want this thing, this new class, right? These rational number objects to behave like real built-in arithmetic operations, right? Like arithmetic objects. So, for example, if I is an integer and x is a floating point number, I can certainly say I plus x, and I can say x plus I, right? So my rats also, I want to be able to commute them. If I can say, as we see up here, if I can say that x plus 5, why in the world can't I say 5 plus x, right? So I can't do it directly. I can't write 5 plus x with just what I have now, but I can actually accomplish this. And the way I can do it is it's pretty straightforward. All I have to do is just overload the operator plus. Now, again, just make sure we understand what overload means. So if I have a function f, right, have some function f, can I give the function f different meanings? Can f means add and f means subtract and f means, can I do that? Well, the only way to overload it, which means, again, it means to use the same name, the same function name, but give different meanings to it, different functionality to it, is by having a different list of parameters, right? So that's called the signature of the function. It's basically the return type and the list of the parameters. And in some instances, we only consider the list of the parameters to be the signature of the function, right? What defines what one function is, signature, right? It's a signature of the function. So the return type, let's say over here, and the parameters I pass in. So I can overload the function many times, just to make sure that it has different signatures. So in fact, I can do it with any function, including the function called operator. Right now, for that, well, we've seen operator plus take just a single argument, right? But we can do the following thing. I can say operator plus is now going to take two arguments. It's going to take a rat x and a rat y. Now let's see what happens when I do that. And it's going to return, of course, a rat, right? So why is this overloaded? Well, first of all, it has a different parameter list. Before it only had one rat. And that's okay if it has only the same return type, but it's still a different function, even though I'm using the same function name. Now, if I define it like this, then what's going to happen, I can then say x plus y, right? Once I define this function, because that's going to be translated into operator plus of, let's say, I don't want to make this up because I call the parameters x and y. Let's say m plus n, where those are rats, and this is going to be simply going to be translated to a call. Not even, yeah, it's going to be translated to a call of m and n, and because those are both rats. So m is going to be x, and so that will work. Now, what about how about if m is a rat plus 5? Will that work? Well, yeah, because what will happen here is, again, m plus n. So that's going to be operator plus of m, which is a rat. And what about a 5, right? M plus 5. Well, that's okay because the 5 is going to go here, and we saw that the compiler, wanting to be helpful, is going to translate the 5 into rat of 5, and rat of 5 is in fact a rat. So that will work too. And what about 5 plus m? Again, m is a rat. What about that? So we saw the previous one didn't work, right? The previous one did not work, but this will, because that's going to be translated into operator plus of 5 and n. Well, now n is a rat, 5 is not. But over here, you see what did not work before is it's not going to create an object on the left-hand side for you to work on. But here, it's not on the left-hand side. In fact, is this a member function? We'll talk about this in a second. It's not a member function. It's not a member function. It's just another function that you define this outside of the class. And we'll see in a little bit there's some things you could do to make it a little bit easier. You define it outside the class, and it uses rats, right? The whole idea is once you define this rat class, anybody can use rats. Anybody can define their own function and take rats as parameters, right? And since you've got this conversion in here, this new version of operator plus, which is not a member function, but will be able to take care of all of those three cases. The case where I have x plus y, where both are rats, the case of x plus an integer, and the case of integer plus x. So in fact, you don't even need the other ones, right? You could just do it like this, right? Why did I show you the other ones? Because that's sort of the traditional way of doing it. But in fact, when you do it like this, then you take care of everything. Now, why is this? Now, I'm saying it's not a member function, right? Why is it not a member function? Because a member function has the following, we saw this before, has the following use case. This has to be an object of the class. And then you say dot. And then you say the function name and pass whatever parameters. Now, this is not that. When I say 5 plus n, when I write the definition of the function, and I say it takes 2 rats, well, that's not what's going on here. The operator plus would have to take a rat and a dot and another rat, right? By some function call. But that's not the syntax that I'm using here. So this clearly not as a member function. It's a function that's defined outside, and that's perfectly okay. Okay. The only not okayness about it is that, remember, we talked about the notion of encapsulation, right? What do we mean by encapsulation? Encapsulation means everything that you need to know about the class is right in front of you, right? You say class, you say the name of the class, you open it, you give the definition of what it looks like, what can it do, and you close it up, and this is your capsule. And I don't have to look any further than this to see what my rats can do. But since this over here, right, this is not a member function. It can't be a member function because it doesn't have the syntax. It doesn't use the syntax of calling member functions. So it's sort of, it's a little kludge, but it does solve our problems. So let's see what's left to do. This is the way we started. We looked at a main program, and we said that we want to be able to have a program that's going to let us do the following with fractions. We want to be able to declare fractions and initialize them. So in fact, I can do that. I can already declare fractions. I can add fractions. I can subtract fractions, or you'll show me how. I can divide fractions. I can multiply fractions. By fractions, I mean rats. I can do all these things. But what can I not yet do? What can I not yet do? I can't do this. I can't print out a rat directly, right? Beforehand, we saw we could say something like, C out, and then say x dot get, the numerator, and then so on and so forth. But I don't want to do that. I want to directly print it out, like you see over here. We can't do that yet. So I can't do this. I can't print it out. Can't print it out. Can't print it out. I can't read it in yet. Can't print it out. So basically, the reading and writing of rats, we can't do. Now, what about this? What about this thing over here that says 3 times x plus, right? So I can't do that yet. But let's see how that might work. I can do x times 3, because we have this conversion. But what about 3 times x? You've got to do the trick that we just looked at. Now, the y times 3, if I, define my operator times outside, again, like we just saw before, that will work. So this is going to give me a rat, and this is going to give me a rat. So I can add these 2 rats. This will be a rat coming out of here, and this is going to be an int, but rat plus int, it's going to use the conversion constructor. So that's going to really become rat plus rat. So this is going to work, assuming that you define this appropriately, right? You define the multiply, all those things. You define them in such a way that we can actually multiply with the integer on the left-hand side, right? That has to work also. So that's what we're going to work on. That's the final thing to look at. We're going to look at basically what's missing is the input and the output. And in order to do that, we're going to have to see something called friend functions. And friend functions are very interesting. They're very important. And we'll see that in the next video. And that will tie together our introduction to object-oriented programming in C++.